Okay, this is just a little review, okay? So, Unit 1A, we did all of these polynomial functions. Do you remember these? And Unit 1B, we did rational functions. We did where they're dividing. So this is just a quick little recap, okay? So, when you have a polynomial function in factored form, what are the pros of this? Like, what are the good things about it? What do you know from it? Just yell it out.
Oh, there's 3x plus 5s.
Okay, so what are those?
Zeros.
Zeros. Yep, and then Michael, if there's 3 of them, what is that called? Do you remember?
Cubic.
Yep, what's another word? Like,
Balance, multiplicity.
yeah, multiplicity.
Balance.
Bones. Yes. So we know the zeros, we know the multiplicity. Okay? Case, are you leaving me notes? What are my pros if it's in standard form?
The degree.
Perfect. The degree. Fantastic. That's a 4. What else do we know?
The shape, and if it's positive.
From the leading coefficient. Yep, the leading coefficient, which is the 3. We know if it's up or down, right? Positive or negative. And then what's the last thing we know? What's this?
Y-intercept.
Y-intercept. Fantastic. So we kind of get little like perks from each different type. So what do I learn from this right here? There's 4 of them. Yep, wholes, fantastic.
Zeros.
Zeros, fantastic from the top.
Asymptotes.
Which one?
The X.
Not both, really.
Vertical.
Just the vertical, right? Because the horizontals down here would because you use your leading coefficient, remember, and your highest degree. So that one, I mean, you can get it from here. You just have to do some work. What's the 4th one? What's the down here? The denominator. Domain. Fantastic. What?
So the vertical asymptotes for those would be -4 and 4.
C, senor.
Okay.
Okay. And then what about if it's in this form, general form? So this was standard, and this is pretty much standard form, but it's just on the top and the bottom. So it's standard form, but they call it general form because you're dividing. So what are my pros from this?
Horizontal.
Yes, horizontal asymptote. I always feel like I'm swearing. What's this one? Perfect, y-intercept. Nice. How are we feeling? Kind of, sort of, okay. Okay, so now, these are 2 examples that you might see on an FRQ. Okay, they'll give you a function and then you gotta list all these things. So if this was my function, what's my degree? Easy point. 3, fantastic. We're gonna skip on behavior. What's the y-intercept? 0. It would be like back here, wouldn't it? What are the zeros?
Excellent
Okay, so what do I have to do?
Factor.
Factor. So I'm going to pull out a 2 and an x. So x squared minus 8x plus 16. And then 2x times, what's this? X minus 4 squared, isn't it?
Yep.
So what are my zeros?
4 and 0.
0 and 4. You guys said that like it's exactly 4 and 0. Perfect. Okay, now, end behavior. I think it would be a lot easier to do where is the function greater than 0 and the end behavior if we sketch a little graph, huh? Okay, so it is an x to the 3rd cubic. So that's going to start down here and do a little snake in the middle and go up, right? Okay, where's my zeros?
It bounces off the 4.
Ooh, good one. it bounces at 4 because there's 2 of them, remember? Since there's 2, so I'm going to start down here, I'm going to go through 0. And then I'm going to come and I'm going to go down to 4. And since there's 2 of them, it bounces, so it's going to go back up. If there was only 1, remember, you go through it. Okay? So now, what's my end behavior? The limit as x goes to negative infinity of f of x. Where is it going? Negative infinity. Perfect. That's down there. And then the limit as x goes to infinity of f of x. Where is it headed?
Infinity.
Positive infinity. To infinity and beyond. Where is the function greater than or equal to 0?
Bracket 0, comma infinity.
Yes, okay, look it. So we're going to start here, and this is above, and this is above. So pretty much from 0 on, right? Now, they're going to start to get pretty particular. See how that line is under there? You have to put a bracket at 0, because 0 is included. 0 is included in the answer. So you just want to make sure you have a bracket there. Okay, so let's try the next one. What's this one? What's the domain? Negative infinity to negative 3, right? Because this is negative 3 and this is positive 1. And then negative 3 to 1. Are either of these included? Like, do I need brackets on them?
Nope.
No, because they're asymptotes. And asymptotes, remember, you're never going to be able to touch it. It is a canyon that goes down to the depths of the universe. What are my zeros?
0 and 5.
Perfect. 0 and 5 up top. Is there any holes? No. None. Vertical asymptotes? Negative 3 and 1. How many times do you feel like you've done this now? A lot. I know, isn't it? Horizontal asymptote.
0.
Nope.
One.
3.
Yes.
3.
You have to remember. You kind of gotta like do some multiplying. So it's gonna be x squared over x squared, but there's a 3 out front of this one, so that makes these cancel out and become 1, and then my horizontal asymptote's 3. Same thing for the y-intercept. This would become minus 15x, and then there's a 0 at the end of that. And then what's the end of this one? Plus 2x minus 3. So 0 over negative 3 is just 0, isn't it? So my y-intercept is 0. How are we feeling? Good? Okay, now we're going to completely change up. Okay?
I hate this.
Yes. Binomial theorem. Theorem means it's been proved over and over and over again. Okay? Remember Pascal
The lizard.
from Algebra 2? Blaise Pascal. I think that's a cool name. Don't you think that's a cool name? I don't know. Blaise Pascal came up with this, which just blows my mind that people come up with these things. Because I'm just not. So remember, you start with ones. Remember this? Start with a 1, and then you add these together to get 2, and then a 1. It's always a 1 on either side. Okay? And then it becomes 1, 3, 3, 1. Now you'll notice. Somebody was like, why when the exponent is 3 do I use this? But that's the 4th row. Because they don't really necessarily count that top row. That's a 0. And then a 1 and a 2 and a 3. I always just remember, you use the row that matches the exponent. Okay? So then it's going to go 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. I think there's a 7 on the back, maybe an 8. So the thing with pre-calc, they're probably not going to ask you to expand it, because that's kind of easy. But like, so they might ask you, like this example down here, find the third term. So they'll want just one of the random terms, okay? Which you end up having to do kind of the same process. Okay, so I did not have a lot of you for Algebra 2, but this is how I taught it, okay? I would never use it for this one, would you guys? I would just multiply them, FOIL them, right? For 3. So I feel like we can just skip that one too and just do 4 to make it, just so we can just do 1. Okay, so if I'm gonna do 4, see how this has a 4? I'm gonna use this row of Pascal's triangle. And how this works is you copy down that row, but you leave space. So 1, 4, 6, 4, 1. Rebecca, have you ever seen this in Germany?
Oh, not really.
No. Ishak, have you ever seen it? You have? You were taught it last year? Neighbor?
I was, but I didn't.
Remember it? Oh. Okay, so isn't that crazy to think, like, where did you move from?
India,
Yeah, where?
Chennai.
Okay, Chennai. Yeah, isn't that crazy to think in all the way across the whole other part of the world, they're learning the same thing that you're learning? Isn't that crazy to think? I know. In Germany, do you think they have to learn it. You just probably do it like next year maybe.
I've seen it, but
Oh, you have?
we never like used it.
Yeah. You've heard of it, but yeah. I know, it just is cool. I think that's cool. It's like the same concepts. Okay. So, it's called the binomial theorem because it only works with binomials. Okay? And binomials mean you have 2 terms. So I'm going to take the first term and I'm going to put it next to every single thing here. So I take that and I put it next to every single thing. And then you take the exponent and you count down. So this one gets a 4, and then a 3, and then a 2, and then a 1, and then a 0. I kind of use different colors just to try and help it stand apart. And then I take the 5. Since it's positive, I can just treat it as a 5. Like that, it's still just plus 5. If it's negative, like in the next one I'll show you, it makes a difference. But with plus 5, I can just do a 5 next to every single thing. And the weird thing here, though, is you don't start at 4, you have to do the opposite. So this one starts at 0 and counts up. 1, 2, 3, 4. So what ends up happening is you end up with 5 terms. Okay? Each of these is its own separate term of your answer. Okay? So 5 to the 0 is 1, times 1 is 1, times x to the 4th is just x to the 4th. So that one's done. And then if I do this one, what's 4 times 5?
20.
Positive 20. So I have to add 20. And that's x to the 3rd. See how you're kind of narrowing it down to your answer? And then this one, and I looked it up, and if you had this on the AP Pre-Calc test, it would be a calculator test. So you would be able to use a calculator. It would be yes, calc. Okay? So that's 25 times 6. What's 6 quarters? $1.50. X squared. And then
1,000.
125 times 4,
Like 1,000, I think.
500. $1.25 times 4 is $5, right? And then last but not least, what's 5 to the 4th power?
Big number.
725?
What are they saying?
Or 625, I think it's
Yeah, it's
625.
6.
625. Okay, so this right here is my answer. And if you think about it, it goes in sequential order, like x to the fourth, x to the third, x to the second, x, and nothing. One thing we were talking about last hour, which I thought was kind of interesting, it's like, last year in Algebra 2, were you all pretty much rock stars? Like you did really well? It was pretty easy?
Yeah.
Okay?
Yeah.
Yeah, so if you think about it, Algebra 2 is a 100% class, meaning 100% of the kids have to take it. So 100% of the kids, we kind of tier Algebra 2 to the lower half because those are the kids that struggle with math. So we give extra reviews and I record videos for everything. Like we kind of hold their hand to help you pass. And then now that you're in, so I think some kids might struggle a little bit with this class because you actually have to understand it. It's not just, I feel like Algebra 2 is a lot of just memorizing. Would you agree? Like memorizing, you know how to do the quiz review, you can do the quiz because they're pretty much the exact same, right? Kinda, sorta. And now you kind of like need to know like the actual math behind, like you're starting to learn like why is it that, Why does that work? So I think going up a little notch kind of, but I think you're fine. I mean, we just had that quiz and your average was an 89, so I know you stress out because it's not 100, because you're probably used to hundreds, right? Yes?
Personal finance.
Pretty much if you're a junior, you need to take this. This is your course. You chose to do advanced math. You didn't?
Seniors could take like
Why?
that was like science, math.
But Florida's behind, aren't they? I feel like academically they're behind us. No? Was it harder?
It was like easier, but it was like farther along the path. Like you can take algebra 1 to 7th grade.
Oh, like they had more offerings. So you did that? So then you just were set up to be in this class, Gavin.
I don't think I've gone over an 80. Actually, over 60.
But it's an AP class, so really that's a 90 if you think about it, right?
So really,
I know, exactly. Okay, the negative kind of throws you for a loop with this one. So you do the exact same thing. You write down the 5th row. So 1, 5, 10, 10, 5, 1. I'm writing that down because of the exponent. Okay? So nothing's changing with my x. That's just x, 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 and then 5, 4, 3, 2, 1, 0. And then this -3. So since this is a -3, I put it in parentheses. If it's anything more than a single thing, I put it in parentheses just to trigger my brain that that's a negative, not -3, And then that's going to be a 0. -3 to the 1, -3 squared, and -3 to the 3rd, -3 to the 4th, and -3 to the 5th. So what do we know about negative numbers? When there's one of them, it's negative. When there's two of them, it's positive. So with this one, when you're doing this, okay, that equals 1 times x to the 5th. So we start with x to the 5th. But then here, when you do this, that -3 stays a -3 and times by 5. You're going to get -15. And you have to minus the 15. So it becomes part of the equation. And then you alternate, if you think about it, because this negative is squared. So that's gonna become 9 times 10 is 90, x to the third, that's that one. What's 3 cubed? 27? Negative 27 times 10 is negative 270. And you will have a calculator. Negative 3 to the fourth is 81 times 5. 405 x, and then minus, so my signs alternate, negative, positive, negative, positive, negative. 3 to the fifth power is 243. That's your total answer. You might see this on the PSAT, juniors, next week, October 16th. Did you ever see it, Bryce?
Ooh, I don't remember. I don't
Remember?
think so. Actually, honestly, I don't think I did.
Yeah.
Wait till you come back and do some great.
Yeah.
Terrible.
Okay, so we have one more problem. Can you try it? Try this one on your own. Find the third term, just the third term of that problem. 2x plus 3 to the 6th.
Is this like 11?
So do we expand it and then?
Like this is like the stuff that we're.
So the third term would be, like, if it was,
It's just a review, yeah.
so if it was asking for the third term, it'd be, and if we use the previous equation, it would be 90x to the third.
No, we're using this equation now.
Well, yeah, no, I'm saying
Oh,
like,
yes,
Okay.
that right there would be the third
So that's
term
what
of
we're
that.
finding?
Huh?
That's
Nope,
what
now they want the third term of this brand new
we're-
one.
That's the same, like, that's what we're looking for.
Yes, yes. I know. How does one person come up with this? Isn't that crazy? And it was back in, when was he alive? Blaise Pascal.
well, there's like nothing else to do, so.
Hey. He was born in, he died young. He was born in 1623. And he died in 1662, so 39.
That was not really a good time to live anyways, so it's not the end of the world.
True. French, he was French. Mathematician, physicist, inventor, philosopher, and writer. So if you write out 1, 6, and 15, did you guys do that?
Yep.
And then this would be 2x, 2x, 2x. And then this is to the 6th, to the 5th, to the 4th. And then it would be 3 to the 0, 3 to the 1, and 3 squared.
Wait, I think it would actually be the fifth, fourth into the third, because there's a 0 at the end.
Huh?
If you touch the fifth, then touch the fourth, and touch the third, right?
No, you copy down this exact same one.
But isn't there supposed to be to the 0 at the end? So
Yeah.
there's only- that would make 7 points then, including the 0.
Well, no, I'm just following this formula. So this one gets a 6, 5, 4, 3, 2, 1, 0.
Oh, okay.
Yeah, you always
Oh.
copy down the same exact. So it would be 15. Now, 2x to the 4th times 3 squared. Here's where some kids will mess up. Where do you think?
The 2x.
Yeah, what do you mean?
You have to put 2 to the 4 as well.
Yes. This is all of the first digit. So when you are distributing that 4, it has to be to both things. Okay? So be careful with that. So really, it would be 15 times 2 to the 4th times x to the 4th times 3 squared. What did you guys get? Perfect. 2160 x to the 4th. Nice job, Erin.
I know something.
You know lots of things. Not math. Yes, you do. 2160. Are we good?